Hello friends, welcome back to this video on greedy method, general method, algorithm design. First, reading out the definition. What is a greedy method? Greedy method is a problem solving strategy used in algorithmic designs. Used in algorithm design where decisions are made step by step, choosing the locally optimal choice at each step with the hope that it leads to a global optimal solution. It builds up a solution piece by piece, always choosing the option that looks best at the moment or perfect at the moment. So, diving into deeper, the greedy method is nothing but a simple step-by-step problem-solving approach. Step-by-step problem-solving approach. Okay? Where we make the best possible choice at each stage. Best choice at each stage. Okay, the one that looks the most promising at that moment. All these are keywords. So it's like always picking the juiciest fruit inside, hoping that doing so every time gives you the best overall basket. So always choosing juicy fruit inside so that it always lead to overall best basket of fruits. So first always think locally, local best option which leads to final optimal solution. Okay, final optimal solution. This is the process followed in greedy method. I hope we are fine now, till now, regarding the understanding. So, when to use the greedy method? Running through the main points. The greedy method works only for problems that have greedy choice property or optimal substructure. So, what is greedy choice property? As already discussed, we can reach the global optimum by making local optimum decisions. That is, a global optimal solution can be arrived at by making a series of local optimal, that is greedy choices. Reaching global, first point is reaching global optimal solution by making local optimum decisions. Local optimum decisions is called nothing but greedy choices. Okay, greedy choices. This is the first point, when to use greedy method. So, going to the second point, optimal substructure. A problem exhibits optimal substructure if the optimal solution to the problem contains the optimal solution to its subproblems. So, we have already discussed in previous algorithms that we always break down the major problem into subproblems, different subproblems. Okay, So what is optimal substructure? The problem solution can be built from solutions to its subproblems. So once the solutions to subproblems are built, once the solutions to subproblems are built, then building the problem solution is also very easy. Okay. So this is optimal substructure. First we will build the solutions to the subproblems and then we'll reach finally at the solution to the major problem. This steps makes us easy. If both these properties are satisfied, the problem may be a good candidate for the greedy approach. So if both these properties are fulfilled by a problem, then we can go for a greedy approach. For example, if there is a problem which can be split into different subproblems and a solution for each subproblem can be attained, then this case is satisfied, and arriving a local greedy choice for each subproblem, and then for the going for the major global optimal subproblem is the second case. If these two properties can be attained or can be chosen for a problem, then we go for a greedy approach. So general structure of a greedy algorithm. So for every problem there will be an input and output. What is input? A set of elements, each with a certain value or a weight. This is very simple. Initializing. Starting with an empty solution. Always we start with an empty solution. That we are with a plain mind that there is no solution to a problem. Now coming to selection process. We will, in this procedure, selection procedure, we will select the best candidate based on the local criterion. Okay. What are we doing here? Selecting the best candidate. Selecting the best candidate based on local criterion. Okay. Next step, feasibility check. Check feasibility, make sure adding this choice won't violate constraints. After selecting the best candidate, we will check whether adding this choice won't violate our constraints or rules. Okay, what will this step do? Check feasibility, make sure adding this choice won't violate constraints. Okay. So ensure the selected candidate. This is dependent on the third step. Fourth step is always dependent on the third step. Ensure that selected candidate does not violate problem constraints or rules like overlapping in activity selection, exceeding weight in the knapsack, etc. We'll look into this in detail. But as of now, feasibility checking is that the candidate selected in the third step, whether we need to add it or not in the solution list based on cross-checking that it is not violating the rules. Okay. So inclusion. If it is not violating, directly include the selected candidate in the solution. Our initial solution is 0 or empty. So inclusion is nothing but the candidate should be added in the solution if it is not violating the constraints or rules. So again, repeat steps 3 to 5. Again, we'll go for another local candidate selection, and if it is feasible, we'll add to the, we will select that candidate and add to the solution. So repeating 3 to 5 steps. Okay. Repeating this steps 3 to 5 until a complete solution is formed or no more candidates remain. Okay, until the final global solution is formed. Output. Now we'll return the constructed solution. Okay, this is the process. So we are looking into the simple pseudocode. So we have already said that we will start with an input. Here we have the input. First step, initialization. We have already discussed that we will initialize at a start. Will initialize during the start with 0, that is solution is empty. This means we have not picked anything yet. So we will loop until we are done. First we are starting with a loop. Okay. So we have already discussed that we will repeat the steps so that we this is a while loop. So we are starting with a loop here. Candidate selection procedure. Okay, candidate selection, best selection from the input. Picking the best item according to rules or constraints. Okay, according to rules, picking the best item. For example, highest value or low cost value or low cost. This is the selection process. If this is feasible means we'll check against the constraint or rule. If this is feasible, we'll add to the solution which was initially empty. We will add that candidate to the solution. Next, if it is not feasible, then we'll skip it. Next, coming to the next input, going to the another option. Okay, going to the next choice or else. Then the same process, picking the best item, that is highest value or low cost. Then again, if it is feasible, we'll add to the solution list. If it is not feasible, we'll skip that solution and go for the other item or other choice. Okay, this is the example of pseudocode representing the greedy algorithm. So, examples of problems solved by greedy algorithm. We'll go one by one. Activity selection process. Activity selection problem. Always pick the activity that finishes earliest, so more time is left over for other activities. So we have already said that we will choose the best item. So what is the best item greedy choice in activity selection problem? So how are we using greedy choice in the perspective of activity selection problem? Always pick the item that finishes earliest. Okay, so that more time is left over for other activities. More time left for other activities. Okay, so what is greedy choice in the perspective of fractional knapsack problem? Take time with the highest value per unit weight first to maximize total value quickly. How are we choosing the item here with respect to a fractional knapsack problem? Highest value per unit weight. Highest value per unit weight. By calculating this, we are taking the best item to maximize total value. Here, final best optimal solution is to maximize total value quickly. Okay. So, how is greedy choice used in the perspective of Huffman coding? Merge two lowest frequency nodes. Always combine the two least frequency symbols to build an optimal prefix code. Combining two least frequency symbols to build an optimal prefix code. Okay. So how greedy choice is used in perspective of Prim's minimum spanning tree? This all will come across in the upcoming videos. Choose the minimum weight edge. Okay. At each step, add the smallest edge that connects a new vertex to the existing tree. So at each step, adding a smallest edge that connects a new vertex to existing tree. A new vertex to an existing tree. Okay. Briefing down with Kruskal's MST algorithm, add the smallest edge without forming a cycle. That is, always pick the smallest edge that does not create a cycle in the growing forest. And Dijkstra's shortest path. Always choose the unvisited node with the shortest known distance from the source. These are all best optimal solutions. So, 1 minute. I think we have not skipped anything. Okay. So, what are the limitations of greedy method? Greedy algorithm does not always produce the optimal solution. There might be some scenarios where it does not provide optimal solutions all the times. Especially for problems like 0 by 1 knapsack problem where a dynamic programming solution is required. This is one scenario. A greedy algorithm may look optimally local but fail globally because it lacks the ability to look ahead or reconsider previous decisions. So, first one is greedy algorithm does not always produce the optimal solutions. For example, 0 by 1 knapsack problem where in this case it is using dynamic programming. So, there is one more scenario. A greedy algorithm may look optimal locally. In local or per an instance wise, it may look optimal or perfect, but when it comes to global solution, it may lack the ability to look ahead or reconsider previous values sometimes. These are the two scenarios where the greedy method may fail. Comparison with other approaches. So, how is brute force algorithm? How is dynamic and how is greedy? So, brute force, as we have already discussed, it checks all possible solutions one by one. Optimality guaranteed, yes, but it takes slow because it will not use any shortcuts or techniques or shortcuts. It's slow. Example, TSP subset sum, that is traveling salesman's problem, or subset sum traveling salesman problem, or subset sum. So what is dynamic programming? Solves problem by breaking them into overlapping subproblems, storing results to avoid recomputations using optimal substructure. So what is going on in dynamic programming? Solves problem by breaking them into overlapping subproblems. First, it will initially break the problem into overlapping subproblems. Step 1. And then storing results to avoid computation. It might be horizontal or vertical. It will store the results, tabulation or memoization. This also we have already discussed, these two concepts. So, storing the results. What is the overall goal of this procedure is storing of results to use it in future, to use them in future. Okay. So, finally, what is our goal? Optimal substructure is our goal. Step 3. What are the steps followed in dynamic programming? First step is breaking the problem into overlapping subproblems is first step, and second step is storing the results to use them in the future without recomputation is step 2, and obtaining the optimal substructure solutions is the step 3 in dynamic programming. Is optimality guaranteed here? Yes, optimality is guaranteed here. Example, knapsack 0 by 1 knapsack problem. So, greedy. We have discussed a lot more today with greedy algorithms, greedy strategies. Local optimal at each step. This is well known as of now. Local optimal at each step. Sometimes if properties hold, is optimality guaranteed? We have already discussed. No, optimality is not always guaranteed. There are scenarios where it may fail, but sometimes optimality is guaranteed. Except these two scenarios, except the scenarios we have discussed above, optimality is guaranteed all the time. Okay. Next, what is the best example of greedy strategy? Activity selection. Okay, activity selection problem is the best example of greedy solution. or greedy strategy. So, what is the simple real life analogy? We are going through simple real life analogy of greedy strategy. Imagine you are collecting coins to make change for a certain amount. If you always choose the largest denomination coin available that does not exceed the remaining amount, you are applying a greedy strategy. Okay. Now we'll look it in detail. So what are we trying to do? We are trying to collect coins to make change for a certain amount. Let's take, I am choosing, I want to collect an amount of 27 rupees with collecting different coins. Okay, with a chance to collect different coins. So I have 1 rupee coin, 2 rupee coin, 5 rupee coin and 10 rupee coin. So we'll start with 27. I have to collect 27 rupees. The biggest coin less than or equal to 27. The simple criteria is select the biggest coin less than or equal to the remaining amount. Initially, what is my remaining amount? 27. So choosing the biggest coin less than or equal to remaining amount. Okay, simple, nothing but remaining amount. Less than or equal to the remaining amount is 27. Biggest coin from this option less than or equal to 27 is 10. So initially I have collected 10 rupees. So what is the remaining amount? After step 1, remaining amount is 17. Now, sorry. So, always I am following the criteria of selecting the biggest coin less than or equal to the remaining amount. After the step 1, the remaining amount is 17. Now, I am choosing the biggest coin less than or equal to 17 now. Okay, biggest coin less than or equal to 17. Again, I go for 10. Okay, now the remaining amount is, this is step 1. This is step 1 and this is step 2. Now the remaining amount is, already I have collected 2 tens. The remaining amount is 7. It was initially 27. I have collected 10. The remaining amount is 17. Then after 17 I have collected 10 and the remaining amount is 7. Now what is the remaining amount? It is 7. Now I have to choose the biggest coin less than or equal to 7 now. So what is the biggest coin that is less than or equal to my remaining amount 7 is 5. Okay, now I will choose 5. So what is my remaining amount? Is 2. Okay, now this is step 3 and step 4. Now biggest coin less than or equal to the remaining amount is 2 is 2. Okay, now what is the remaining amount? It is 0. So I have chosen 10. I have taken the greedy choice of 10 here, greedy choice of 10 here and greedy choice of 5 here and greedy choice of 2 here, making the final optimal solution. This is the real life example of greedy choice at each step. Okay. So, summarizing, greedy method is powerful algorithm design paradigm that is efficient and easy to implement for the right kind of problems where it is the problem is satisfying the two greedy properties. Okay, before applying greedy strategy, we'll check whether it is satisfying the greedy properties or not. However, it should only be used when the problem guarantees that a local optimal choice leads to a global optimal solution through the greedy choice property and optimal substructure. These two properties need to be kept in mind. Thank you.